Okay, so let's start our first class. So make sure you have registered for FIS2033 June semester. So make sure you already passed your chemistry FIS chemistry 1. Okay, so chemistry 2, basically all this you can read in the island. So what we're going to cover is all these 8 chapters: ceramic bonding, chemical bonding, gases, the state of liquid, solid, and intermolecular forces, right? Solution, acid and alkali or base, chemical equilibrium. So by the end of, for your test 1, you'll cover 1 to 4. Test 2, you'll cover 5 to 8, all right? So electrochemistry and organic chemistry. So these are the 8 chapters. Learning outcome, these are the things that we will test you. So there's the way how we design the question. So first, question 1, section A, normally will ask you to explain the concept of the theories. Theories means equation, some certain technical word, and all this. All right. So B or ClO2 is your calculation, your analytical thinking. Right. So from the answer from section B or ClO2, you this one is C is your lab lah. It's your lab. Right. So from 2 you explain something. Right. So these the 3 things lah. Okay. So this is my name. My name is Dr. Ang. Right. Okay. Mobile you already have. All right. So how do I assess you? You have 50% coursework, 50% final exam. So so test, you have 2 tests. Each one is 10%. So you add the 10%, 2 together, get 20. Assignment 50%. Assignment for this module will be easy, where your assignment question will be, I will select from the tutorial sheet that I give you. Basically, I just take the question that we discussed in the class, you reapply the answer for the assignment. So basically, 50%, you show 100, get 50% already, if you pass up your assignment. Okay, this one. So this one I help you already. If you get 0 means you do not pass up, or you forget to pass up. Okay. In our class, I'm quite strict in the due date. If I say 12 o'clock means 12 o'clock. 12:01, I do not receive anymore. So I'm quite strict. So lab report 50%. This one is like other module. You follow the format. There's a certain structure how you write the report. Okay. What I want to see is your analysis. Means you do experiment, then you explain why. Why is the observation? Then explain why. Okay. With your lab report, you need to cite a certain textbook. You need to do citation. You know how to do citation? If no, later I will explain, right? So that one later when we come to lab session, I will explain how to do, right? So final exam, I already explained to you. Final exam will cover chapter 1 until chapter 8, but I will give you some hints what are the specific 4 chapters that going to come up. You will have 4 questions. Or maybe 10 questions, I'm not sure. Normally, I will just design for 4 questions. 1 question, 25 marks. Okay, all compulsory lah, compulsory to answer all. All right. So these are the grades that you are familiar. What I expect you will be somewhere here. In mind. So if you Chem 1, you get C something, forget about your C chemistry 1. But in my class, if you attend 100% in my class, I assume you already at A minus level. This one you need to work hard a bit lah. Okay, in our class, I will also mention what are the tricks that I use to ask you in the question, in the test or final exam. What is my trap? How I trap you? How I trap you? A certain way I trap you, so you need to pay attention when in the class lah. Okay. All right. So week 1, we'll do chapter 1. Week 2, we'll do chapter 2. But I think we'll do chapter 2, chapter 1, some of the chapter 1 next week also. It depends. So today we'll go a bit slow and relax first. Then next week we'll go a bit faster. All right. So I can see here my plan will be, your test 1 will be in week 7. Maybe your practical will be in week 7 also. Because you have 3 hours. Your test will be 1 hour. Test 1 will be 1 hour. Then you do practical and so on. So we try to arrange how. Maybe if we finish chapter 4 faster before week 6, then we do practical first. Then we do test in week 7. Okay. And then I'll give you assignment in week 7. You pass up your assignment in week 13. Week 12 lah, week 12 maybe, week 12. So here I put week 14. This is my last date to pass up your assignment. Normally assignment I give you 1 week lah, but I give you more than 1 week to pass up, because some of the answer you need to stay until week 12 when we cover chapter 8. Okay. All right. So these are the textbook that I use throughout this whole semester. Right, so these 3 books you can go and find, all these ebooks or textbook. All right. All right. So these are the 4 elements that is inside your learning course structure. Some topic I'll go a bit deeper because you need it for your degree level. All right. So I'll go deeper, but these are the main things. For example, chapter 1 will go. Although here, these 4 are the big things that in your syllabus. But in our class for chapter 1, we will cover 8 things. Okay, so we go into first slides here. All right. So first we look at the bonding models. Why we need to study bonding models is start from a case, that HIV case lah. You know what is HIV, right? So some researcher, and then they find a protein that contribute to the diseases. So that is the starting point lah, where scientists start to look at the bonding. Okay. Right. So to design such molecule, researchers start to use bonding theories. I highlight the word in yellow, means it's important. So you can start look at your tutorial question. Normally it will be in the blank. You need to fill in just to strengthen your learnings. All right. So what are the bonding theories? So we take NaCl, for example. You know what is NaCl, right? Salt. Right? It's a garam that you use in daily life. In chemistry, we name it as NaCl or sodium chloride. Okay. So bonding theories, what is bonding theory do? They predict how atoms bond together to form compound. You will see this word compound throughout the whole semester. Compound means product. You on the left side of the equation, normally in chemistry, left side equation, let's say A plus B, you will see an arrow plus C plus D. On the left side of the equation is usually your input or reaction, reactant. We call it reactant. Reactant. On the right side of the equation, this is the process lah. It's the process. Arrow is the process. The right side is your product, or in this case we call it your compound lah, or your something like that. Okay. Before we go deep, these are the framework or fundamental ideas that we need to do. So usually for test one, to help you to score marks, we'll ask you why bonding theories, they are the central to chemistry. The answer lah is to predict how atoms bond together to form compound. Okay, so they predict combination and all this lah. So this one you read Okay, so water is salt is sodium chloride. Water chemistry 1 H2O. H2O. So later we'll look into detail why positive, why delta positive, why delta negative. Okay, so recall what you learned in the chemistry 1. So basically class number 1 is basically just to recall what you learned in your chemistry 1. So valence means outside electron. They are electron in the outermost principal shell. So this is what you learn. So you have orbit number 1, number 2, number 3, number 4, number 5. This is what you learned in chemistry 1. There's energy if you want to move from one orbit to another orbit. From low orbit to high orbit means to move from 1 to 2, you need high energy. Means you give energy to the atoms at that certain orbit, then it will move faster, vibrate, then it will move to another orbit. If you want to shift to a lower orbit, let's say orbit number 3 to number 2, there's a process called relaxation. What do you mean? You use the energy. Use the energy or you take away the energy, so it will move from high orbit to low orbit. Okay. So the effect that you see physically, if you move a certain molecule or atoms from one orbit to a higher orbit, there's energy absorption, means you need to give energy. Right? Okay. So this one you read. So you read. What is excitation, emission? This one is already done in chemistry 1. Okay. Then you learn Lewis model or not? No. Cannot recall. Okay. So valence electron, valence means the electron outside the nucleus. Valence means outside electron. Valence, right? So they are important in bonding. So chapter 1 is about bonding. How molecule connect to another molecule. It's called bonding, right? Then we will use Levi's model. This is called Levi's model. So in the test or final exam, you will be instructed something like that. The question will go something like that. Use Levi's model to illustrate the structure of hydrogen, for example. So you need to draw something like this. Okay, so technical word for today, Levi's model. Right? Means orbit. Center sphere. You need to draw the center sphere and then circle, 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 circle. Then label. Maybe you don't need to label because we can see what does it means. Unless you are the orbit is a lot more than 5 or there's a high number, then you need to label what is that orbit. Okay, can So when the question you see in the question I mentioned Levi's model, straight away in your mind you need to give me something this presentation. There are certain keyword in the question one. When you see Levi's model, something like this is expected. Okay. Okay, Levi structures in the, or you can call dot structure, simplified version. Okay, so they are represented by dots. Now we're going to how do you answer for your test 1, normally question 1 answer question. So electron configuration for oxygen. What is the equation for oxygen? Equation for oxygen? Oxygen, how you write oxygen? O, O2, right? So when you need to do Levi structure, normally you need to refer to periodic table. In your chemistry one, you're familiar with periodic table, right? So in your handouts also, in your tutorial, there is a periodic table there. I give you two versions. One version is this version, another one is another page. Okay. Now, but the way of arranging the periodic table is the same. You have group number 1, 2, 3. It means in column, from the top to bottom. In column, it means group number 1, then move to 2. Then you see the number 3 here. Then B here means it means something, right? Usually we only see A. Only see A. 1A means it's a very common element. B means something it will happen when you mix with something else. So for foundation, normally we will look at group A element. Means group 1, group 2A, then move to here. Group 3, 4, 5, 6, 7, and 8. Okay. So you familiar with this one, periodic table? Yes? Okay. So O is at here. Right? O is at here. You need to be good a friend for with this periodic table throughout the semester. This will be your good friend. You need to answer almost all the questions referring to this one. Okay. And then what does the row mean? What does the row mean? Just now I explained about the column. What does the row mean? What does the row mean? Size of atomic number 50%. Got correct and incorrect. Okay, I draw something on the whiteboard. For those watching online, apologize. So drawing something on the whiteboard. So this is periodic table. Just now we talked about column, right? This column is how many electrons you have outside the orbit. This is valence electron. Okay, so if you are row column number 1 and 1, and 1. Column number 1, A, what does it mean? It means your orbit, this is nucleus, orbit only have 1 electron outside. You familiar with this one, right? I mean this presentation, right? So what does it mean? The far right, this is 8, right? Group 8. What does it mean? Means you have 8 electron outside. So in orbit, to be stable, as you learn in chemistry 1, to be stable, what does it mean? You need to have how many electron outside the orbit to stable? Only 2 magic number. It's like orbit is like a race car lane. Okay. To be stable, to have a stable, especially when you learn about bonding. To be stable, minimum you need is 2 electron in the orbit or 8 electron in the orbit. Yeah, these are the magic number. This is the golden number, 8, 2 and 8. So this is a concept that we expect you to understand in your chemistry 1. So this is important, especially for this chemistry 2. You need to understand what is stabilized atom or molecule. Okay. Okay. Next, we move to, just now is column, right? Next, we move to row. 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 Okay, so I take row number 1. Row number 1. Row number 1, I just put N1. What does it mean? This one is number of orbit you have. Means if you look at row number 1, hydrogen and helium, He, if you draw the Levi's model, you only draw one circle. Means you have one orbit. Row number 2 means they have two orbit. Okay, I explain. Okay. How to make sense when you draw the orbit? I take NE. I take N. Maybe I put oxygen lah. Our case is oxygen lah. Oxygen is in row number 2. And 2. Periodic table, you look at row, column, and row. You look at the column first. So this is column number. How many? Column number? You can count, right? How many? 6. Okay. Column 6, what does it mean? You got 6 electron outside the orbit. Then you look at the row. Row number for oxygen, row number 2. What does it mean? You have 2 orbit. So when you draw the model, outside got how many? 6, right? You put 6 with X or dot lah, or usually we put X or dot as a electron. Oh, so this is 8 already. Okay, you draw something like this. Okay, Levi's model, we will represent all these. Okay, you know that you got 2, right? You got 2 orbit, right? What is the number to get stable for orbit? Minimum 2. So inside got 2. Of course, there's some formula to calculate lah. But later on, I'm not sure you learn in your chemistry 1, there's a certain formula to calculate maximum electron inside the orbit. But for oxygen, this is what I draw on the whiteboard. Any question? Make sense? Okay. If you confused, you just ask. You don't stop. Okay. So I already explained, like from the periodic table, you already can imagine the presentation of the atom already. Okay. So this is another periodic table that you will see in your exam. This is another set, but still same. It just gives you the different metals and non-metals with the colors lah. So if you print out without colors, maybe it a bit hard for you to recognize. But if you print with colors, you will see with that. Okay. 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 Titanium. Why I highlight titanium? Okay. Okay. This is just a recap how you use the periodic table. So let's say we look at titanium. Right. So you start with labeling your periodic table. So this is N1. You start labeling N1. Then this row will be 1s2. N2 will be 2s2, 2p2. You recognize this one in your chemistry 1, right? So I continue. Row 3, you have 3s2, 3s6. Later I'll give you the cheat code for this one on my slides. If you forget I give you. Okay, so start labeling. The first two column, you label as S. The column number 3 on the right, 3A, 4A, 5A, 6A, 7A, 8A, you label as P. S on the left, P on the right. What else? Okay. Add additional, special case for helium. You need to label S because you might be confused with this P. Right? So only for helium is S, it's belong to S, it's not P. Then you label the middle one from the blue color or group 3B until group 2B. This whole group you label D. So you have SDP. Okay. Okay, the rest I'll just skip. Okay. So you already learned how to do long answer and short answer. So for example, titanium. If you base on all this labeling, titanium is over here. So you read from the first row. So first row, all you have is 1s2 because this is one. Okay, this is one element, two element. So you have 1s2. The second row, you continue to count 1, 2, 3, 4, 5, 6, 7, 8. These two belong to S. These two, Li and Be, belongs to S. So you write 2s2 because 2 means is in the second orbit. 2s2, 2p6. Why 6? Because in the P column, you can count 1, 2, 3, 4, 5, 6. Then you continue. Number 3. Number 3 is here. So 3, you have 1, 2. 1, 2 is S. So you have 3s2. Then you continue here, have nothing. Remember, this will be the confuse or mistake from the student. You will continue to count here. I don't know, somehow, some of you will jump to here and count. You will somehow, I don't know, you look somewhere else and then you count here. Okay, so just be careful on n equal 3 here. You need to count 1, 2, 3, 4, 5, 6. So you have 3s2, 3p6. Then you continue to count until you find titanium. So titanium stop here, right? So you have 1, 2, you have 2s, 4s2, and then this is inside D already. So you have 1, 2, D. So D2, D2. So you have this one, this whole thing, right? So this is very long, right? As you go down, it's very long answer. You can straight away take the far right element and put bracket to represent the in front representation. Because argon, Ar equal to all this answer. Okay, so answer you can bracket Ar 4s2, 4d2. This SDP is the orientation of the electron. How's the electron move and all this. This one is what you learned in your chemistry 1 already. Good. So maybe your chemistry 1 lecturer do not give you this trick. Now only you can see this actually the trick lah. Okay, but for chemistry 2, we actually do not ask you this one anymore. We assume you already understand. So when you answer later for chemistry 2, you should already know, we expect some orientation of electron. Okay, then continue to add inside your periodic table there. This is also a cheat code for that. So this column is called 3D. This column is called 4D, 5D, 6D. Because you know that at a certain orbit, electron will jump back to a certain orbit. So this is why we modify a little bit the labeling on the periodic table. Normally, the student wrong answer, if I ask titanium again, you will put somewhere wrong answer, you will put straight away somewhere lah. You'll miss out the 3D there. Okay, so this is the wrong answer previously. The correct answer is because titanium it belongs to 3D orbit. If you write 4s2 4d2 means it's wrong answer because you don't understand the basic of periodic table. Okay, so the correct answer should be because it's inside this 3D column and not 4s, the normal calculation. So the correct answer for titanium will be argon bracket 3d2 4s2 because it involves this here. This is 4s2, but this column, blue color section, this section is labeled as 3D. Okay, so this is the chemistry one that we expect from you. So just recall back what you learned in the chemistry one. Okay, yeah. 3. Oh, you write this one first and then 3D too. Not the correct orientation because in this module, if you see numbers, we will write the low number first, then high number. We won't like flip the 4 and then 3. We'll arrange our answer in the alphabetical order, our numbering order. We won't write like 4 1 or we won't write 4 comma 1 something, but we'll write 1 comma 4 something. Give alphabetical order and numerical order in the sense. Of course, if you write 4 first, 3D is actually not wrong chemically, but it's just that people, when you say see your answer, then we know you don't have a proper training lah. Means your lecturer do not teach you well to organize your answer. I mean, if you write 4S in front 3D2, it's still a right presentation for that particular element. But if you communicate with the expert, they know you don't have the right foundation. So you might be confusing when you read textbook. Why this author write a certain way and my lecturer allowed me to get the correct marks, although I write in a certain way. Okay. Okay. Sorry, there are 2 more. Add in your periodic table, 4F and 5F. This is a cheat code lah for periodic table reading. Although I won't ask you this in our module lah, chemistry 2, but this is the fundamental that we expect from you. Okay, back to oxygen. So oxygen will be, when I mention 2s2 4p2, you should able to understand already by using the cheat code that I give you here. When I mention electron valence orientation or arrangement, I write in a certain way. I write in 2s 2p2. You should already know what does it mean. Okay. So I go very fast. So it answer these slides. For oxygen, it should be 1s2, 2s2, 2p4. Right? So I spent like about 10 minutes just now to explain these slides so that you won't blank. Okay, so I will do it in this way kind of teaching. If you think that, oh, it's very boring, you don't need to answer the previous theory, then you let me know. I will just go fast. Okay. Okay, so means that you have 6 electrons and the structures will be draw like this. So in chemistry 2, if you see the question asks you to draw the Levi structure, we expect you to draw with the dot. Chemistry 1, you will draw with the orbit. But in chemistry 2, we'll start to see dot because we will involve a loss of element. It might confuse you if you use circle. Yeah. So from the left to right, I hope you can understand, or straight away read from the row and column of the periodic table. Okay, so the proper presentation for electron, let's say O, will be 2 parking lot on the left, 2 parking lot on the top, 2 parking lot on the right, and 2 parking lot on the right. Let's say this is any general element. I just put a capital A. I write something on the whiteboard. Let's say this is element A. If you want to answer the question for Levi structures, remember the proper way of writing your answer is 2 on the left, 2 on the top, 2 on the bottom, 2 on the right. You don't squeeze all in one, unless when we go into bonding later. This is just before we go into bonding, these are the fundamental concept. All right. Okay, this one you read. Okay, now this is the tutorial question. Okay, go for another maybe 15 minutes, then we go for a break. Or if you think you can continue, then we continue. All right, so this is I think question number 6 in your tutorial. So by using the periodic table, try to answer for 1, 2, 3, 4, 5, 6, 7, 8, these 8 elements. Maybe each one of you answer 1, then we move on. Okay, if you're able to understand already. So maybe Ivan, you answer Li. Joshua, you answer for BE. And Cheryl, you answer for B. Okay, I give you maybe 1 minute. You should be able to finish drawing the Levi structure. Okay, Levi structure now is not circle, but it's dot. Use a dot to represent. Okay, the structure I already give you on the whiteboard. Okay, give you 1 minute, and you tell me what is your answer. Okay, those watching online, you can fast forward the video to another maybe 1 minute ahead. Okay, done? Okay. Now I, BE, and B. So when you're ready, you can come in front and draw the Levi's answer. I give you black pen. When you're ready, you can come to the front and write the Levi's structure. Just try, just try. Never mind. I won't come. Go to the front and draw. Okay. Usually we use dot. We use dot. We use dot. We just circle, make it circle. We use dot for Levi structure. Because the definition for Levi structure just now is we are using represent with a dot. Okay, seems that every one of you able to answer. Okay, let's check Li, correct or not? Okay, Li, where is Li? Li will be here. Sorry, I give you the. Okay, Li will be here, right? Will be here. So Li will be group number. Li will be. What does it mean by group number 1? Row and column just now. Periodic table, row and column. Column, group 1, what does it mean? External electron. So Li will be Li here, right? Group 1, right? So it should be how many? 1, So pay attention, This actually is, if this one come out in a test 1, it's actually a free mark question. It's basically recall what you learned in your chemistry 1. Okay, we check BE. BE is group number what? BE in the periodic table, group number 2. So that's why you see 2 dot. And so on. B is group number 3. Right. So this is also wrong. Okay. So Ivan and Joshua need to pay attention a bit. This actually is a free mark. No? It's a very, very easy question. Understand? Okay. Okay. Just to test, Ivan and Joshua. Let me see. If I give you AR, how many dot? AR. How many dot? How many dot? Ivan? 8 dot, correct. Good. If I give you SI, Ivan, hey, this is Ivan. Sorry, Joshua. 4. Okay. So this is just a recap. Okay. So I already give you answer in the slides, so you can check. Okay. So Levi structure actually help us to see how many valence electron. So in your answer in the test or final exam, use the wording that inside our lecture notes or in my PowerPoint slides. Don't use something like external electron. Use valence electron. These are the words because our marking scheme is based on the keyword. If you write something outside the schema, we are unable to give you marks. Okay, right. So one new keyword just to recall, if we have 8 electron valence, means in the periodic table is a far right, we identify them as a octet, 8 dots. Means they have 8 electron. If the question mentioned this element have octet is atoms, it means it belongs to something wrong with the network. Okay, can so this is a technical keyword . So if the question, sometimes question we don't give you direct answer, we'll just mention use an element from that consists of octet atoms that can form compound and so on. Then continue with the calculation and so on. So if you see octet, it means in your mind you need to know already it belongs to element from the group number 8. Means it's having 8 electron outside or 8 valence electron. Yeah, important, huh? So this is just like a keyword. When you see question, it mentions certain word. What does it mean? So it belongs to group number 8, not including helium. Just now helium is special element. Helium is only one element. Okay, so it's from element number 10 until 10, 18, 36, 54, and 86. All right. So these are the two things lah. This is what you learned in your Chem 1, Chemistry 1. Okay, we go fast a bit. Helium, helium is special. This is just a reminder. So it's 2 dot. So just now, octet is mean 8 electron outside or electron valence. You have 8. If you have only 2, it means duet. D-U-E-T, duet. Duet means you have 2 pair dots. Yeah. So later, in a later session, we will keep mentioning duet and octet. Because you need to use these 2 keywords to answer section C question. Why it is a stable atom? Yeah, I start give you hints already. Why this is the stable atoms? Your expected answer is because based on Levi's structure, the atoms or the molecule contains duet or octet. Or is the octet atoms or it is duet atoms, right? Okay. Right, can? So we have learned Levi's model, we have learned duet, we have learned octet. Be careful on your spelling also in the exam. You might write something else, D-U-E-L is wrong spelling. Octet also something that we expected if you're not careful. Octet, some of you might write octet. You might miss out the C, or you might add another T behind, O-C-T-E-T-T, also wrong. Spelling is very important for the chemistry. Okay, can okay, not can okay, so this one you can read. So how to read stable? The word stable, stable means you have duet or octet, means 2 electron or 8 electron outside, or 8 valence electron or 2 valence electron. So sometimes the question will be a bit tricky. It will ask you how to obtain stable atoms. That means you find the missing electron. If it only have 7, then you add 1 electron. If you only have 1 atom, you add 1 more. 1 electron, you add 1 more electron. To achieve these 2 criteria, either 2 or 8. So if the electrons are transferred, we start to learn the first bond. It's called ionic bonding. If electron is transferred, means electron is moving, then we have ionic bonding. The word is transferred. Later you will see another word called shared. This is called transferred. Okay. So in your chemistry 1, normally how to form ionic bonding? Okay, I give you notes here. These are small notes. How to form ionic bonding will be metal plus non-metal. So from the periodic table of this one, this version, you can see different color. Which is the light blue will be represent metals, dark blue will be represent non-metals. Means if you take metal plus non-metals, you get ionic bonding. This is the periodic table. So basically, this will be given in the test or final exam. So once the question asks you, what are the possible what are the possible compound that can form compound with the ionic bond? Means in your concept, in your answer, we expect you to write to form ionic bonding. I mean, this is the sentence that we expect. Means we try to guide you to answer what is ionic bonding. So in your answer, you need to write to form ionic bond, we need metal plus non-metal. This is the keyword that we expect in your test. Yeah. So for foundation, if you are not looking at your English, if you're lazy, you can just write this presentation also. I give you correct. Means that you understand. Yeah. So if transferred is ionic bonding, if shared, it is called covalent bond. So there are two bonds now, ionic bond and covalent bond. The keyword is shared and transferred. Transferred means you throw away or you receive. It's like a basketball. If you receive, if you take a basketball, you hug or you throw away, it is ionic bond. If you share the balls, basketball, then they are called covalent bond. You imagine the outside electron or valence is a basketball or ping pong ball or something that you're familiar with. Okay, so foundation actually is a transition from SPM to university level degree learning. You cannot use what you use for SPM into a degree level. It's a transition. Because SPM, you half out, then you throw what you learn in the exam. In university degree, no, you need to answer why. Okay, so if you use back the SPM learning style, you can only answer section A of the chemistry 1 question. Means you memorize. We don't test your memorize actually, and very low marks for section A actually. Okay, so let's say 10 marks for one question. Section A maybe 2 marks, 3 marks. But section B maybe 5 marks or 6 marks. Calculation and answer why. Okay, there's a difference. All right. So again, ionic bond and covalent bond. You should be able to answer based on the a statement given in the question. You're finding the keyword lah. If you see transferred, means ionic bonding is expected. If you say shared, then you expect covalent bonding. All right. So this is to answer section C or explaining why. Based on your calculation or your diagram, you explain why. When you take element A plus element B, then if element A share with element B, the electron, it means they are formed covalent bond. If atom A transferred electron to B to form another compound, it means you have an ionic bonding. For the products, the output. And these are the idea. Okay. So again, normally we will use the octet. Again, octet rules. This one you read. Okay. So if chemical bonding, there are two types of bonding, ionic and covalent bonding. So we will use transferred or share. It depends on the element. All right. So again, how you know it is ionic or compound? is only can enter into one category only. It will not be at the same time have ionic and covalent. No. Means what? You look in a question, if you see metal plus non-metal, confirm ionic question already. If you see the question mentioned shared electron, means confirm it asks you covalent bonding question. But if you ask you to guess what is the bonding, then you need to see the element. Okay, it asks you to estimate the type of bonding, means you need to read the periodic table by using the two definition. You need to answer. To answer that, first you need to give a definition of ionic bonding. What is ionic bonding? Metal plus non-metal. What is covalent? Shared electron. It can be metal. It can be normally is covalent. Normally is kumpulan number 4 lah. Means it will be fourth group or those non-metals. Okay. So these are the tricks. These are the tricks. Okay. This is just an additional presentation just for your learnings. What I mean by transfer means something moving. It's like a basketball to represent the electron, right? So if it's throw away or receive, it means it's a ionic bonding. If it's shared like this in the orbit, it means it's a covalent bond. Okay, so this presentation is expected in your answer to justify it is an ionic or covalent. So what is the application from what we learned since the morning? Just now, since beginning, we know about Levi's model. You need to draw Levi's model. The question will give you element A, element B. You need to draw Levi's model. Then the question will ask you to define whether the combination A plus B is ionic or covalent. Then you think back, definition for ionic, metal plus non-metal, and transferred. Use the word transferred in your answer. Electron was transferred. And then you go element table, go and find. You ask you, okay, give an example for your answer. So you go to the element table, you find one metal, find one non-metal, put inside here. The red color is metal plus non-metal, the blue color. You draw the Levi's model, you draw arrow, you write transferring electron. Then it will form two individual atoms. See the orbit or not? The gray color means it will form two individual atoms. With this one, or they have octet rules. They need to comply the octet rules. This one. If the question mentioned octet rules, what is expected in your answer means we want to see 8 electrons in your answer. Don't use the cross. Don't use the cross. Use dot or round shape to represent electron valence or valence electron. Correct? Can absorb or not? Can? At least you have some idea how we ask you, then how you answer. Okay. All right. Just now we talk about octet rules. So the question might ask you, what is octet rules? Means this one. Means you have 8 electron. The keyword is 8 electron in its valence shell. This is what we expect in your answer. Okay. So this one, it applies to all main group elements except the two in the top of the periodic table, which is hydrogen and helium. The question in final exam will something like this. The octet rules Does octet rule apply to all main groups element? I will ask you. Put a question mark, then you answer. Your answer is yes or no. The answer is no lah. If the question is the octet rules apply to all main group of elements? Question mark. The answer is no. Then you need to write lah. Octet rules generally apply to all main group elements except hydrogen and helium. This the green the yellow color is what we expect lah, except these two elements. Okay. All right. So these are just an illustration lah. Means you'll be given a periodic table. The two top members, they do not apply to octet rules. Why? Because they only have one orbit. One orbit maximum is two. They are the most inner one, so they have two electrons. Okay, they're quite special lah. This one. The rest is 8. The rest is 8. All these members without helium and hydrogen, all these outside must obey octet rules. Means every time if the question do not ask you hydrogen or helium, all the member below these two, we expect you draw 8 dots in your answer. Okay. The rest you read. Okay. So we have this exercise, then we go for a short break. Levi structures of phosphorus and magnesium. Are you able to draw? You'll need to flip to the periodic table. Okay, the periodic table. Phosphorus is P. Phosphorus P. Now, of course, in the test or test 2 or final exam, we will help you with the bracket of that element. This is just tutorial question. So we don't properly structure the question. But in the test, we will straight give you phosphorus bracket P and magnesium bracket Mg. But of course, for oxygen, that's normal one. We won't give you lah. Okay, P. Ivan, group number is group number 5. So got how many electrons? 5. Joshua, magnesium. Where's magnesium? Mg, group number 2. Okay. Cheryl, I'm not worried about you. So P, you have 5. Mg, you have 2. Okay. So these are extra exercise. Okay. Which are the 2 elements have the most Levi structures? Let me see. I have to answer. This one you answer during your free time, during your revision. This one I think I have to answer also. So you check. You need to check. This is just a revision of concept. But before this, all you understand, right? This one you do lah. You do. They have to answer. I labeled for you. Okay. I will stop here. Then we go for a short break. Let me stop the recording. Give you the next instruction.